Okay. Yeah. So we discussed about in different layers how your web traffic can be secured. If it is in the network layer, we will use IPsec. In transport layer, we have SSL or TLS, secure socket layer or transport layer security. And in application layer, we have seen applications like Kerberos, PGP, SMIME, set we have to discuss. We will do that by end of this chapter. Okay, so with this knowledge, we are concentrating more towards SSL, the architecture of SSL. Okay, so designed to make the TCP use of TCP to provide a reliable end-to-end secure service. Okay, so how do you secure TCP using SSL? Exactly. How do you secure TCP data communication? It is using uh, uh, SSL, not a single protocol, but rather two layers of protocols. I wanted to tell you this. SSL, secure socket layer, is not a single protocol, students. There are two separate layers in SSL, and every layer have one or two protocols running in it. So what are those layers? What are those protocols? We will see today. So the two layers of SSL are Ssl Record Protocol. You can see in the diagram given here, SSL protocol stack, the network layer IP, and in transport layer TCP. Above that, you can see SSL Record Protocol, and that is the bottom layer of SSL. And in the top layer of SSL, you can see SSL Handshake Protocol, SSL Change Cipher Specification Protocol, and other one is SSL Alert Protocol. So under SSL, we have four different types of protocols: SSL Record, SSL Handshake, SSL Change Cipher, SSL Alert Protocol. HTTP, it is protecting the HTTP data. That's what it means. So HTTP, whatever seen in the diagram, is not part of SSL protocols. Is that clear, students? So I suggest you to write this diagram. It is very important. So you on the top layer you have application, and bottom you have TCP, and below application layer, transport layer, and network layer. And between application layer and transport layer, you can see this SSL protocols. And SSL, there are two sub layers of SSL that is located between application layer and transport layer. And in those sub layers, in the top layer of SSL, you have SSL Handshake, SSL Chain Cipher Specification Protocol, SSL Alert Protocol, and in the bottom layer of SSL, you have SSL Record Protocol. So what is SSL Record Protocol? It basically provides security services to various higher level protocols. Is that clear? It provides security to higher level protocols. Three higher layer protocols are defined as part of SSL: Handshake, Change Cipher Specification, and Alert Protocol. So two important SSL concepts: SSL session and SSL connection. You should know the difference between these two, students: the connection and a session. A session is an association between client and server. Sessions are created by the Handshake Protocol. What is a connection? Every connection has an associated every connection is associated with one session. Between any pair of parties, there might be multiple secure connections. Is that clear, students? That's the difference between SSL sessions. A session is basically an association between client and server. Is that clear? Association in the sense like what parameters you are exchanging, like what will be the type of data, what is the size of data that you are sending. Those parameters will be exchanged in the session. And what is a connection? Every connection is associated with one session. At least there should be one session in every connection, and there might be multiple sessions in one connection. Is that clear? So between a pair of parties, there might be multiple secure connections also. So that's the difference between SSL session and SSL connection. You have to define as it is for session and connection. If you get a question, the definition of session and connection should be similar to this. Is it clear? So number of states associated with each session. Once a session is established, there is a current operating state for both read and write. Is that clear? So once a session is created, you can either read or write from that session. So this is the basic architecture. I mean, the outer look of an architecture of SSL. So do you have any questions in this, students? Shall we go to the next slide?
Sir,
Yeah.
sir, what does this session layer brings adds to the security? Like in the application layer, we have, for example, HTTP has HTTPS, and in transport layer we have TLS, and in network layer also, you said about IPsec in the last class. So, what does this add more? And by security, there
See,
can be
in
many ways
transport
to secure.
layer, you don't have transport layer security. Okay, you can either go for transport layer security or secure socket layer. Is that clear? So transport layer security is not a default option for transport layer. You can either go for SSL or transport layer security. And if you are going for secure socket layer, this is the architecture of secure socket layer to protect the transport layer data. Am I clear?
Sir, I asked because you told it comes before transport layer, no, sir.
Yeah, it
SS.
is in between. See, it is like in between transport application layer and transport layer. It's a small, you can say, extension of transport layer. Is that clear? It is basically placed between application layer and transport layer. That's the location of this SSL. Is that clear? Because it works keeping the sockets in mind. Is that clear? So where are sockets located? If you recall, sockets are also located in between application layer and transport layer. Sockets are basically door from application layer to transport layer. And if you can protect your sockets, uh, obviously the data is secured. Is that clear? So who is going to protect this socket? Basically SSL, or you can go for TLS. The architecture of TLS is totally different compared to SSL. We are not worried about it, but when you protect a socket, you are protecting the transport layer. Is that clear? Because the data is coming to transport layer from application layer through a socket only.
Yes, sir. Clear, sir.
Okay, so this is the architecture. So let us jump into the protocols of it. In addition, during handshake protocol, pending read and write states are created. Upon successful conclusion of the handshake protocol, the pending states become the current states. Is that clear? Generally, when you establish a connection before handshake or during handshake, pending read and write states or sessions will be created. Once the successful conclusion of the handshake, those pending states become the current state. Is that clear? A session state is defined by the following parameters. So as I said, you lot of parameters will be exchanged in a session. Session identifier, what certificate you are using. It is X.509. We have seen that version 3 certificate of the peer, both the peers. Compression method, which algorithm you are using to compress the data. Prior encryption. Is that clear? Before encryption, you have to compress here. Cipher specification, that means bulk data encryption algorithm such as AES, a hashing algorithm used for MAC calculation. Cipher specification means what encryptions algorithm you are using. Is that clear? So master secret, so 48-byte secret shared between the client and server. Uh, is resumable, a flag indicating whether the session can be used to initiate new connections. So all these are parameters of a session. A connection state is defined by the following parameters. So these are the parameters for a session, students. What are the parameters for a connection? Server and client random byte sequences that are chosen by the server and client for each connection. Then server write MAC secret key used in MAC operations on the data sent by the server. Client write MAC secret, similar to the server write. Clients write also will have a MAC operation. Server key write, client key write, or write key. So see, all these are the keys which you are using to encrypt and decrypt. So don't worry much about what is a write key, read key. So we are not going in depth towards that. What you have to understand is basically we use keys for encryption and decryption. So initialization vectors first initialized by SSL handshake protocol. Sequence number may not exceed 2 to the power 64 minus 1. For your data, there will be, see, in the transport layer you will be using secret sequence numbers, but apart from that, even the SSL layer also adding a sequence number for your data. Is that clear? These are the parameters for a connection, and we have seen the parameters for session also. So that's about the connections of session and connection data. Now let us see SSL record protocol. So what does it do? We have already told it provides security. Okay, let us see in depth. Provides two services for SSL connections: confidentiality and message integrity. I mean, part of security. Okay, so handshake protocol defines a shared secret key used for conventional encryption of SSL payloads. So that is the confidentiality of that is provided by the record protocol. Message integrity, we know what is integrity. The handshake protocol also defines a shared key that is used to form a message authentication code, that is MAC. MAC is message authentication code. Okay, and then yeah, this is one important diagram, students. SSL record protocol operation, and I suggest you to write this diagram. So SSL record operation: fragmentation. Each upper layer message is fragmented into blocks of 214 bytes or less. Major work of SSL record protocol. So keep this in mind. SSL record protocol is in the bottom layer of SSL. Out of two layers, SSL record protocol stands at the bottom. Is that clear? So compression must be lossless and may not increase the content length by more than 1024 bytes. Is that clear? So we are not dealing with the calculation of MAC, students. Don't worry about it. So you can see, if you have a application data, if that is fragmented and then it is compressed in the third level, and once it is compressed, you are calculating a MAC for it and adding it or appending it to the compressed data, and then after adding the MAC to the compressed data, you are going to encrypt it, and then you are adding a header, that is SSL record protocol header. Is that clear? Please go through this diagram, see this diagram for a while. If you have any questions, let me know. So is it clear, students? SSL record operation. The major operation is fragmenting the data which it receives from the top layer of SSL, and then compressing it, adding MAC to it, then encrypting the MAC and compressed data, finally adding a header record, okay, record header, and then it sends that to the TCP layer, I mean the transport layer. So the TCP segments, it will be added into the TCP segments. So received data are decrypted, verified, decompressed, and reassembled before being delivered to the higher level to the users in the receiver side. Is that clear? So following encryption algorithms are permitted. For stream encryption, the compressed message plus MAC are encrypted. For block encryption, padding may be added after the MAC prior to the encryption. I will give you an explanation about stream and block encryption later. That's a separate chapter, students. We will discuss that later. Then final step of SSL record protocol is processing is to prepare a header consisting of the following fields. So that is content type, major version, minor version, and compressed length. These are the fields in the header of SSL record: content type, major version, minor version, and compressed length. Is that clear? So you need not go through this diagram, student. It is not required for you. Yeah, that's about SSL record protocol. Three more protocols we have to discuss: SSL handshaking, chain cipher specification, and what is the other one? Alert protocol. Okay. So next thing is content type defined as change cipher specification, alert, handshake, and application data. So change cipher specification protocol, that is in the upper layer of SSL. So what does it do? It is a very simple protocol, students. Just one byte of it. There is only one byte. So consists of a single message which has a single byte with value 1. What is the purpose of it? Pending state to be copied into the current state. As I said you, whenever there is a SSL handshake, there will be sessions created or for write and read, which will be in say pending state. And once the final of handshake is done, or once the handshake is completed, that pending state has to be moved to the current state. Is that clear? So for that, we will be using change cipher specification protocol. Purpose: pending state to be copied to the current state. This will update the cipher suite to be used on this connection. Is that clear? You are using a cipher suite. That means what protocols you are using for authentication, integrity, confidentiality. So basically, this protocol will update it. Is that clear? This will update the cipher suite to be used on this connection. Is that clear? So generally it will be 1 byte. Is it clear, students? So that's about change cipher specification protocol. Alert protocol, to convey SSL related alerts to the peer entities. So alert protocol is used to convey SSL related alerts to the peer entities. So alert messages are compressed and encrypted as specified by the current state. So you can see there are two options. So the first one will be like basically a warning, and then the second will be fatal. So see, okay, the two fields are level and alert. In the level, if it is 1, it's a warning. If it is 2, it's a fatal. Is that clear? So first byte, warning or fatal, to convey the severity of the message. So what is the purpose of this message? To convey SSL related alerts to the peer entities, right? The SSL alert protocol work is to convey SSL related alert to peer entities. That means the end devices. So how does it informs that there are two fields in alert protocol? You can see both of 1 byte. First one is a level. So first byte is basically tells whether it is a warning or a fatal, to convey the severity of the message. So what will be fatal? SSL immediately terminates the connection if it is fatal. Other connections on the same session may be continue. Is that, sorry, I said you while informing about you about session and connection, I told you there might be multiple sessions in a connection. It is the other way, students, please keep that in mind. Is that clear? In a session you can have multiple connections. Is that clear? So I made that mistake there, please keep that in mind. You can have multiple connections in a session. So if it is a fatal, so it immediately terminates the connection. The other connections on the same session may continue. Is that clear? So basically that particular connection have some issue. That's why there is a fatal alert from the SSL alert protocol. So if there is a fatal alert, that particular connection will be terminated, and if there are any other connections in that session, that will continue. But no new connections on the session may be established until it is basically resolved. Is that clear, students? What is the second byte? A code that indicates the specific alert. Very important. See, you are giving a warning. What is that warning? Where exactly a problem has occurred, that has to be verified. And if there is a fatal, so where exactly the error has been generated, what is that error? So to clear that, you need to have an idea about what it is. For that, the second byte is used, a code that indicates a specific alert. List of alerts that are always fatal. So unexpected message, bad record MAC, decompression failure, handshake failure, illegal parameters. These are some of the fatal alerts. Example, is that clear? So some of the warning alerts: close notify, no certificate, bad certificate, unsupported certificate, certificate revoked, certificate expired, certificate unknown. All these are examples for warnings. Is that clear? Warning alerts. The above one is fatal alerts. Is that clear? You can see the severity there. If the decompression is failed, the data what you have sent is a failure, because you can the data is compressed, and if the receiver can't decompress it, it's a failure of the data. Obviously it is a fatal. But whereas if you take an example of warning, bad certificate, that's a kind of warning. Still, even keeping the bad certificate, you can continue your connection. It's a warning given to the peers that the certificate which is being used is bad. You can change it. Is that clear? You need not uh, uh, terminate the connection there. Is that clear? You can still continue the connection by making some alterations. Is that clear? So that's about the alert protocol. And every one, like all these fatal alerts or warning alerts are associated with a specific number or a code. Is that clear? That code will be informed in the second byte field. So when the user looks into that code, user will
Excuse,
understand. Yeah.
you're showing the slide of chain cipher spec protocol and alert protocol. Okay, now only slide got changed.
Oh, is it?
Yes, sir.
Then why didn't you tell me? From long time I was discussing about this. Hope you can see the alert protocol format, level and alert. Can you see that, students, now?
Yes, sir.
Okay. So that's what I was trying to tell. Alert protocol has two fields of each, like each of 1 byte. And the first is level. It tells what is the level. If it is 1, it is just a warning. If it is 2, it is a fatal. And in the second byte, it displays what exactly it is by giving a code, and every code is associated with a specific warning or a alert or a fatal. Okay. So unexpected message, bad record MAC, decompression failure, handshake failure, illegal parameters, all these are fatal alerts, whereas some of the warnings are close notify, no certificate, bad certificate, unsupported certificate. All these are some of the examples for fat alert warning. Is that clear? Warning alerts. So all these are associated with a specific code, and whenever a receiver receives an alert message with a specific level and code, it will understand how to what extent it is, and if it is a fatal, immediately it will terminate the connection. It keeps all the other connections in the session, but it terminates this particular connection, and it will, until this problem is resolved, it will not create any other connection in that session. Am I clear, students? Hello? Shall we go to the next slide?
Yes, sir.
Okay. So next thing is handshake protocol, an important one, because that is how the SSL starts. So most complex part of SSL allows the server and client to authenticate each other, negotiate an encryption and MAC algorithm and cryptographic keys to be used to protect data sent in SSL record. Used before an application data is transmitted. So application data is transmitted to transport layer. Is that clear? Consists of series of messages exchanged by client and server. There are more than 10 messages. That means every handshake protocol will exchange around 12 to 13 messages, students, in each time. Is that clear? What is the use of handshake? Basically to discuss about what what keys you are using. That's what, negotiate an encryption and MAC algorithms, what algorithm you are going to use, what are the cryptographic keys you are to use to protect your data. So basically client and server will discuss about this in the handshake protocol. Is that clear? And once the discussion is done, finally you are coming out with a cipher suit. Basically what cipher, what protocols you are using for protecting, or what algorithm you are using for encryption, for MAC, all those things. Is that clear? So you can see the handshake protocol header, 1 bit type, 3-bit length, and more than 0 bytes of content. All are bytes, not bit. Okay, parameters associated with this message are will be there in the content. That will be definitely more than 0 bytes. Is that clear? We will see in depth about handshake. You can see here, this is the handshake message which I told you. There will be more than 12 to 13 messages that are exchanged in 4 different phases. So first, client will send a client hello message, and for that server will send a hello message. That's the first phase. Establish security capabilities including protocol version, session ID, cipher suite, compression method, and initial random numbers. That means a client will say hello to the server and it will exchange all its possibilities. That means these are my cipher suits, I can use these algorithms, all those information will be given to the server, and server also will do that. And after that, that's the first phase, and just after that, server will respond with a certificate. Is that clear? Server will send a certificate, key exchange and request certificate, server signals, and end of hello message phase. Is that clear? So I'll explain you that. Server will send its certificate, its key exchanged, and it will request for the client's certificate, the third message, and then server hello done. It is like terminating. So okay, for me, whatever the cipher suits you have used, your communicating is fine. Take my certificate and the key exchange, server key exchanges also, then it request for the client to give its certificate, and it will say okay, I am done with the connection, I'm okay with it. That is second phase. And for that, in the third phase, client also will send its certificate, because server is expecting its certificate, and client's keys will be exchanged, and then certificate verify. That means client will say okay, your server's certificate is verified. That is in the third phase. Client sends its own certificate requested by the server. Client sends its key exchange. Client may send certificate verification also. Is that clear? So 3 messages in the third phase. And in the last phase, change cipher specification. We all know why change cipher specification is used, because it converts the pending session state to the current state. So you need to go for change cipher specification protocol there. Only then your communication starts. So client sends a change cipher specification message, and then it sends finished. For that, server also should change should send change cipher specification and finished. Is that clear? 4 messages in the last phase to convert a pending state session to pending state, a session from pending state to current state. Is that clear? If you count totally in the first phase 2 messages, second phase 4, third phase 3, and fourth phase 4, it is totally 8, 11, 13 messages are exchanged here. Is that clear, students? So the more information about each type of message is given in the table left hand side. So initial exchange needs to be establish a logical connection between client and server. Yes, so this is the handshake protocol action, students. So you have any question regarding this, please go through the diagram, try to understand the diagram. Again, this timing diagram is also very important. Please go through it for a while, 1 or 2 minutes. If you have any questions, you can ask me. You can see the diagram now, students.
Yes.
Okay, okay.
Just now,
Yeah, I moved to the next slide. Again, I have come back to the previous slide. Uh, you can see the diagram now, right?
yes, sir. Yes.
Okay. Just go through the diagram for a minute. Let me know if you have any doubts. Okay. So hope this is clear to you, students. Then we'll move to the next slide. Yeah, phase 1. So the explanation of each phase is clearly given to you here. Whatever I have discussed, the same thing is explained in the slides. You can go through these slides by yourself, students. So I am not going to discuss this. Each phase is explained properly. So just go through these slides by yourself. You need not go through like the hash code, how hash code is generated, what are the certificate types, keys, those things you need not go through. Just a outer look of in each phase what happens, you can go through that. So yeah, all these things are not required. Generation of key material, master secret creation, those things are not required. Generation of cryptographic parameters, that is also not required for you, students. So that's about SSL. Next we have transport layer security, that is TLS. We will take that in the next class. So hope SSL is clear to you. It's a very big topic actually. SSL have two separate layers. It's not a single protocol. And in the bottom layer, you have record protocol. In the top layer of SSL, you have SSL handshake, chain cipher specification, and alert protocol. In SSL handshake, you have 13 different messages which are exchanged to create a session. And initially, a session will be in the pending state, and then it will move to the current state with the help of chain cipher specification protocol. And if there is any problem in your connection, there is an alert protocol which informs that based on the severity of your problem, it will give either warning or fatal, and it also informs about what kind of a problem it is. And then finally the data comes to the record protocol. In record protocol, what happens, the data is segmented, and then a MAC is added to it, and then it is compressed, and then it is encrypted, and then record header is added, and then it is sent to the transport layer for TCP communication. So am I clear, students? That's all about the SSL. We have TLS, the next topic. We will discuss that in the next class. We are not going in depth like how we discussed about SSL. We are not going to do that for TLS. Just an outer look of TLS we will see, and we will move to the next protocol, that is SET, Secure Electronic Transaction. Is that clear? So we will stop here today. If you have any doubts, you can ask me, or else we can leave the meeting. Is it clear, students?